Hey everyone, welcome back to my channel AK Coding, and today we are diving into one of the most popular concepts in the distributed system design, that is CAP Theorem. If you are preparing for system design interviews or working with databases like MongoDB, Cassandra or DynamoDB, understanding CAP Theorem is must. Have you ever wondered why databases cannot have it all, like consistency, availability, partition tolerance at the same time? That's where famous CAP theorem comes in. In this video, I will break it down in simplest way possible with examples, and you will never forget it. What is CAP theorem? CAP stands for consistency, availability and partition tolerance. The theorem says in any distributed system, you can only guarantee 2 out of 3 properties, never all 3 at the same time. Let's quickly define them. Consistency. Every read get the latest write, meaning when you want to get any information from the system, it will provide you latest information and it would not provide the old data. That's the consistency. Availability. The system always responds even if some nodes are down, meaning if any nodes, any distributed servers are down, then the system will try to get the information from the active server or recent information without any error response. Partition tolerance. The system continue to operate even when network failure split the system into the part. Right? Let's suppose if any network or power outage happens in particular node, even though the system operates successfully. It sounds abstract, right? Don't worry, let's see with example. Let's connect with a real life analogy that will help us to get the clear picture. Imagine you and your friend are editing share Google Doc. If the internet is perfect, you both see the changes immediately. But what if connection drops? Do we stop editing until network is back? This is consistency over availability. Or do we let both you keep editing on offline mode even if changes conflict later? That's the availability over consistency. Either way, you are tolerating a partition, that is network failure, but we must choose between consistency and availability. Let's understand the CAP triangles and trade-offs, that is pros and cons. Here is the famous CAP triangle. CP systems, that is consistent plus partition tolerant. Example, HBase, MongoDB in certain nodes. AP systems, availability plus partition tolerant. Example, Cassandra, DynamoDB. CA systems, consistency plus availability but not partition tolerant. Practically impossible in large distributed system because network failure is always possible. Please note, CA system is only possible in monolithic architecture where single system work, and it will not support cloud native architecture. So in real world distributed databases, you always assume partition tolerant and then choose between consistency and availability. Now let's take the real world example. First, let's take the CP example. Banking system is the best example of CP system. You would rather reject a transaction than allow inconsistent balance. When you deposit money in the bank or withdraw money from ATM, your balance sheet would be the consistent across the system. Number 2, AP example. Social media is the best example of AP system. Social media feeds better to show slightly old post than not show anything at all. If users see any error page on your social media, it might be chance to user move on other social media platform. That might be the loss of business. Number 3, CA. CA system is not possible in the distributed system, but you can develop a monolithic application that will work on single server. CA system is fit in your POC like use cases, but not fit in the distributed environment with cloud native architecture. That's why different databases are designed differently depending on the use cases. So, CAP theorem is not just theory, it's a guide to design distributed system. Always remember, partition tolerant is a must in your system design, and you pick between consistency or availability based on your business needs. That's it. If you found this video helpful, don't forget to like, share and subscribe for more awesome tech insights video. See you next time. Until then, keep learning and keep designing.